Hi there. I'm going to be going over the review latitude and longitude assignment. Let's look at question number 1. From which location would an observer never see Polaris in the nighttime sky? The answer here is letter D. It's in the southern hemisphere. Let's look at number 2. The map below shows 4 major time zones in the United States. Let's go to the question. What time is it in New York City when it's noon in Denver? So if it's noon in Denver, it means that this whole zone right here, it's 12 o'clock. If I go to the east, my time will increase. So it would be 1 in this zone, and in this zone it would be 2. So the time would be 2 p.m. Next page. The time-exposed photograph shown below was taken by an observer in the northern hemisphere to record the apparent path of stars. What's the name of the star in the center? That would be Polaris. Polaris doesn't move as all the other stars appear to rotate around Polaris, or revolve around Polaris, rather. If an observer on Earth views Polaris on the horizon, the observer is located at the equator. So number 4, the horizon would be a 0-degree angle. Number 5, the diagram below shows an observer viewing star Polaris. They're looking up 52 degrees, so their latitude is 52. Number 6, what is the latitude and longitude of point X? They give some clues that measurements are 10 degrees by latitude and 15 by longitude. So if they're 10 degrees by latitude, it's be 0, 10, 20, 30, 40, 50. 50 degrees north, and longitude would be 0, 15, 30, 45 degrees west. So our answer is letter B. Okay, the map below shows 3 locations labeled A, X, and B. Which table correctly indicates the solar times at these locations? When the time at X is B. Let's just make this a little bit bigger if we can, to zoom in a little bit on this, okay? So here's the idea here. The time at X is 12. Oops. 12 noon, so 12 p.m. That location. Location A is over here 90 degrees away from location X. So the difference is 90 degrees. And I take 90 and divide that by 15. I get a 6-hour difference. Now, since it's to the west, its time is going to be less, which means that 12 p.m. minus 6 hours would be 6 a.m. On the other side, at location B is located at 45 degrees, so the difference is 45 degrees with location X. We take the difference and we divide that by 15 and find out that we have a 3-hour difference, and that 3-hour difference is going to be an increase because we're to the east. So if it is 12 noon at X, it's going to be 3 hours later. It's going to be 3, oops, I erased everything, but it's going to be 3 p.m. over here. And that matches up with table B here, where it says A is 6 a.m., B is 3 p.m. All right, an observer is looking at Polaris. They're looking up 20 degrees. Their latitude would be 20 degrees north. Let's go to the next page. Whoops, going back. Okay. On this one here, what we want to do is we want to figure out if it's solar noon at X, at which location will solar noon occur at next. So it's solar noon at X, so right here it is 12 o'clock. And letter C, looking at letter C, C is at about 95 longitude, while X is at 80. So this is about 15 degrees over, which means it's 1 hour later. So the time over here would be 1 o'clock. This one over here is at 110, 80 minus, or 80, difference of 110 minus 80 is 30. Divide that by 15 and you get a 2-hour difference. So right now at this location, it's 2 o'clock here. Letter B has a longitude of about 65. 65 to 80 is 15 degrees, so this is 1 hour behind. So over here, the time is 11 o'clock. And location A is at 50, whereas this is at 80. So this is 30 degrees back, which 30 divided by 15 gives you 2. So this is 2 hours earlier. So that makes this 10 o'clock. Now, if it's solar noon here at 12, it's already past solar noon here. It's 1, 2. Our next solar noon would be at location B. What is the latitude of this observer? Well, since we measure from the horizon up, it would be 66.5 north. A ship crosses the prime meridian. An observer on the ship measures the altitude of Polaris to be 60. What's the ship's location? The altitude of Polaris tells us that it's going to be 60 degrees north, and crossing the prime meridian tells us it's 0 degrees longitude. The angle of a star Polaris above the northern horizon can be used to determine an observer's latitude. As a person travels due west across New York State, the angle of Polaris will, well, since you're not increasing your latitude or decreasing it, stays the same as you go west or east, it would just remain the same. Let's go to question number 14. At which map location does Polaris appear to be highest in the nighttime sky? So that would be the highest latitude. So Miami would be the location. And what is the approximate latitude and longitude of the sunken ship? Well, here's the markings of the sunken ship, and you can see through this line here that the latitude is slightly less than 20, and the longitude is somewhere between 68 and 71. We also know we're in the northern hemisphere, so let's say this one over here can't be a right answer because it's in the southern hemisphere. All right, so it's neither can letter C. So it's either this or this. Are we in the eastern or the western hemisphere? Well, since the numbers are going up as we go to the left, it means we're in the western hemisphere. The prime meridian is out here in the Atlantic Ocean, across the Atlantic Ocean, of course, going through England. So we're in the western hemisphere. So putting everything together, we get letter B for this, 20.5 degrees north, 70 degrees west. Since Denver has a longitude of 105 and Utica's longitude is 75, sunrise in Denver occurs. Well, let's figure out how many hours difference there are here. And the number of degrees difference that we have here is a 30-degree difference in degrees. And if I take 30 and divide that by 15, I figure out that there's a 2-hour difference. So there's a 2-hour difference between the two. I know automatically it's not C or D. Now I got to think about this. Utica, they experience sunrise. Let's say they have sunrise at 7 o'clock in the morning. When it's 7 o'clock in Utica, according to this, being Denver's in the west, it's going to be 5 o'clock in Denver. And if sunrise is at 7, Denver will have to wait 2 hours later. So our answer would be B. A person knows the solar time of the prime meridian and the local solar time. What determination can be made? Well, just like I was saying, if a sailor wants to find their longitude, they have to have a clock set to the prime meridian and use the sun to find their local solar time. So the answer is C. It would be the longitude of the person. All right, let's check out this next page. Which two observers would be experiencing the same apparent solar time? If you are on the same longitude, then you're going to observe the sun reaching its highest point at the same time everywhere along that longitude line. So B and E are on the same longitude line. They would experience the same solar time. And so would A and D if they were one of the answers there. What is the altitude of Polaris, the North Star, above the northern horizon for observer A? Well, it's going to be 10 degrees north because the latitude, or 10 degrees rather, because the latitude is 10 degrees north. Okay. The lines on which set of views best represent the Earth's latitude symbols system, I would go with letter B because from the side, when we look sideways, we see the lines of latitude going across like this. But when we look from the poles, we see circles. Number 21, which statement about Polaris is best shown illustrated in the diagram shown? So Polaris is at the equator, is on the horizon. New Orleans is about 30 degrees high. And at the North Pole, it's directly overhead at 90. And the idea with this is that Polaris' altitude is equal to location's latitude. Okay, time zone question. So here's our 4 United States continental time zones. The basis for the difference between the adjoining time zones is the fact that the Earth is spinning or rotating at a rate of 15 degrees per hour. So 22 would be letter D. Number 23, if the time in Buffalo, New York is 5 a.m., what would be the time at San Francisco? So if it's 5 right here, let me just put down a 5 over here. If we were to travel to this zone right here, the time would be 4 because we're going to the west, time becomes less. If we travel to this zone right here, the time becomes 3. And if we travel to this time zone right here, the time would become 2. And so our right answer is 2 a.m. Okay, number 24, the diagram below shows an instrument made from a drinking straw, protractor, string, and rock. This instrument was most likely used to measure the altitude of a star. So if we aimed this at Polaris and found the angle we were tilting up to find Polaris, we could get our latitude. The diagram below represents the route of a ship traveling from New York City to Miami. Each night, a passenger on the ship observes Polaris, and because they're going from a higher latitude to a lower latitude, each night the altitude of Polaris is going to decrease in the northern sky. So the answer would be A for that. Number 26, we're looking at this. It looks kind of like a protractor here, but this is the angle of sight to see Polaris. So we want to figure out what this angle is right here. Now, there are altogether 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes in this 90-degree span here. So each box is worth 10. So if I counted up here, that'd be 10, 20, 30, 40. And I'd have a 40-degree angle right there, and the observer would be saying that they were at 40 degrees north latitude. Let's go to the next page. What is the approximate latitude and longitude of location A? So to get the latitude, I'm going to follow location A in here, and I get about 15 degrees north. To get the longitude, I'm going to drop down here, and here's 150. This is about 165 and then 180, so going by 15s. This might be about 160. Now, the numbers are increasing in this direction here, so I know that I'm on the western part of the world. The prime meridian's over here. You can see that label there. So this would be west. So it'd be 15 degrees north, 160 west. Okay. Identify the city labeled on the map where sunrise occurs first each day. And since our time gets less as we go to the west, the later time would be New York City. So New York City would get the sunrise first, and then as the day goes by, the sun rises in Buffalo, and then Mobile, and Milwaukee, and so on. It starts moving towards the west. Identify 2 cities on the map where the measurements of altitude of Polaris are within 1 degree of each other. So since the altitude of Polaris is equal to your latitude, there are a couple cities that appear to be almost on the same latitude, like Omaha and New York, or Buffalo and Milwaukee, or Reno and Denver. Those would all be decent choices as far as stating that they're about 1 degree from each other. State the number of degrees of longitude that separates New York City from Reno, Nevada, and the difference in hours. All right, so let's take a look at New York City. New York City is located right about here, pretty close to 75. And Reno is located right over here, pretty close to 120. So let's just round it off and say 75 and 120. And if we subtract the two from each other, I believe we get 45 degrees difference. Now, since the Earth is spinning at 15 degrees per hour, a difference of 45 would be a difference of in degrees. 45 divided by 15 is 3-hour difference. So if it was 7 here, it would be 6 here, 5 here, 4 here. 3-hour difference altogether. All right, thank you for listening. Hope this helped you. Good luck on your quiz tomorrow. See you later.